This is A2physics 5, May 2009, question 2a, and this is on magnetic fields. State in words Faraday's law of electromagnetic induction. And so that is your law. I'll just write it to the side in symbol form. E is equal to minus delta phi over delta t. And the way we say that is that the magnitude of the induced EMF is directly proportional to the rate of change of flux. Now it says there, a flat coil of wire is placed with its plane perpendicular to a magnetic field. The flux phi through the coil is initially constant, but changes with time t as shown in figure 2.1. So if I just scan in a wee bit there. So this is figure 2.1, and you can see the flux changing from a constant value and then decreasing to zero and then becoming negative, and then it's starting to increase back to zero again. On the blank axis below this graph, draw a graph to show how the induced EMF E changes with time t from t equals 0 to t equals tf. So if I just write beside the equation, E is equal to minus delta phi over delta t. And so the rate of change of flux there is the gradient of that graph. So you can see in the first part of the graph there, this part of the gradient, there is no gradient, the gradient is equal to zero, and so then just EMF is equal to zero there. There's no flux being cut, in other words, in that first part of the graph. Now the next part of the graph has got a negative gradient. That whole part there has got a negative gradient. But because your equation for the direction of the induced EMF, you have a minus in there, which indicates that it's in the opposite direction to the change that produced it. If this is a negative gradient, then this part here has got a positive value, and it's a constant positive value because the gradient is constant. And so we're going to give it a constant positive value. And it's positive again because the gradient is negative, but two minuses over in this equation make a plus, and therefore that's got a positive value, a constant positive value. And then the last part then, this has got a positive gradient, but again, of course, it is in the negative part of the graph. But it also really, because it is positive and the equation is minus that, then you've got a minus value. And again, it's a constant value because it's a constant gradient. This part here is a constant gradient. And so that's what your graph will look like. I'm just going to do the last part of the question on a blank piece of paper. Part 2, the magnitude of the gradient of the tangent is at times marked A is 600 degrees per second. I'm just going to do the next part on a blank piece of paper. It says for part B that the output voltage of a simple AC generator changes with time t as given by this equation. A is equal to 320 times the sine of 314t. Calculate the frequency of the generator. Now we know from that equation, the normal equation is equal to, E is equal to BAN omega, which is obviously that first bit, and then the sine of omega t. And therefore omega from that equation must be 314. So omega is equal to 2 pi f. So 2 pi f is equal to 314. And when you work that out, 314 divided by 2 pi gives you 50 hertz. And that's your answer for part 1. Part 2 says calculate the minimum time in milliseconds for the output of the generator to rise from 0 to 160 volts in each cycle of operation. So that means that your induced EMF has gone from 0 to 160. So it's 160 minus 0, which is 160. And that's equal to your equation 320 sine of 314t. And we want to find out the value of this t. So you're going to have to do a bit of rearranging here. So 160 divided by 320 is equal to the sine of 314t. And be very careful, your calculator has to be in radians to use this equation. Sine to the minus 1 of 160 over 320 gives you 314t. And therefore t is equal to the inverse sine of this divided by 314. And therefore t comes out to be 0.0017 seconds. And you're asked for your answer in milliseconds. And so if you count 1, 2, 3 decimal places, that's 1.7 milliseconds is your answer.